Welcome to Chapter 8, Monitoring the Network. First we'll see the Syslog protocol, Syslog Operations. Syslog uses UDP port 514 to send event notification messages across IP networks to event messages collectors. Syslog is the most common method of accessing system messages that networking devices provide. Many networking devices support Syslog, including routers, switches, application servers, firewalls, and other networks appliances. The Syslog login service provides three primary functions: the ability to gather login information for monitoring and troubleshooting, the ability to select the type of login information that is captured, and the ability to specify the destination of captured Syslog messages. On Cisco network devices, the Syslog protocol starts by sending system messages and debug output to a local login process internal to the device. These messages can be retrieved without the need of accessing the actual device. Syslog messages might be sent to an internal buffer only viewable through the CLI of the device. The network administrator might specify that only certain types of system messages are sent to various destinations. Popular destinations for Syslog messages include a login buffer, the console line, the terminal line, and the Syslog Server. Syslog message format. Cisco devices produce Syslog messages as a result of network events. The format of these events have a numerical number level attached. The smaller this level is, the more critical it is. You can see the complete table on your left, and each level has its own meaning. The warning level and the emergency level indicate that an error in the software or hardware has caused some malfunction in the device. The severity is determined by the numerical value of the level. You have the debugging level, level 7. This is the less critical. This level indicates that the messages are output generated from issuing various debug commands, and the notification level is only for information. Device functionality is not affected in any way. Interface up or down transitions and system restart messages are displayed at the notification level. Service timestamp. When the service timestamp log uptime in the global configuration mode command is entered, the amount of time since the switch last booted is displayed on log events. It can be used datetime instead of uptime. This forces each log event to display the date and time associated with the event. The clock on the networking device must be set manually with the clock set or automatically with the network time protocol. You need to put in the server the command NTP master 1, and in the device that is being set, you put the command NTP server IP address with the NTP address to allow the software clock to be synchronized by an NTP time server. Configuring Syslog. To view Syslog messages, a Syslog server must be installed on a workstation to have a user-friendly interface for viewing Syslog output. It parses set output and displays it in columns that are fairly easy to understand. The default login. By default, Cisco routers and switches send log messages for all severity levels to console or buffer log messages. To enable these two settings, use the login console and login buffer command. The show login command displays the default login service settings on a Cisco router. router and switch commands for Syslog clients. To configure the router to send system messages to a Syslog server where they can be stored, filtered and analyzed, you have to take 3 steps, or 2, that would be optional. First, configure the destination hostname or IP address of the Syslog server in global configuration mode. We can see the first command input, login, followed by the IP address. The second step would be control the messages that will be sent to the Syslog server with the login trap, followed by the level and command. You can see here login trap 4 would be the level. And third option, it's optional, you can configure the source interface with the login source interface command, followed by the interface type and number, and on the global configuration mode. This specifies that Syslog packets contain the IPv4 or IPv6 address of a specific interface, regardless of which interface the packet uses to exit the router. We can see on the right the Syslog server installed on a computer with Windows 7. You can see it's the interface is displaying the output in different columns. Verifying Syslog. You use the show logging command to view any messages that are logged. You can add changes. For example, the show logging pipe include change state to off command ensures that only interface notifications stating that the interface has changed to state off will be displayed. SNMP SNMP Operation. A simple network management SNMP is an application layer protocol that provides a message format for communication between managers and agents. The SNMP manager is part of a network management system, NMS. The SNMP manager runs SNMP management software. We can see the SNMP manager and the SNMP agents in the image. These are the elements of the simple network management. Its operation. SNMP agents that reside on managed devices collect and store the information about the devices and its operations, then is stored by the agent locally in the MIV. The SNMP has 2 primary requests, which are get and set. We can see all the operations that perform with this request in the image next to on your right. SNMP agent traps. And NMS periodically polls the SNMP agents residing on the managed devices. It queries the device for data using the GET request. Using this process, a network management application can collect information to monitor traffic loads and to verify device configurations of advanced managements. It can display this information via GUI on the NMS. Average, minimums or maximums are calculated. The data can be graphed and so on and so on and so on. Although this periodic polling of SNMP have a few disadvantages. For example, there is a delay between the time that an event occurs and the time that is noticed, because this polling doesn't occur constantly, it's periodically. And there is a trade-off between polling frequency and bandwidth usage. It's possible that to mitigate this problem, The SNMP agents try to generate and send traps to inform the NMS immediately of certain events. Traps are unsolicited messages alerting the SNMP manager to a condition or event on the network. We can see the use of an SNMP trap in the figure on the left that alerts the network administration that the interface Gigabit Ethernet 00 has failed. The NMS software sends the network administrator a text message, pop up a window on the NMS software, or turn the router icon red in the NMS GUI. We can see in the second image the exchange of messages between the manager and the SNMP. SNMP versions. The versions available, the most important are SNMP version 1, the simple network management protocol, a full internet standard defined in RFC 1157. The SNMP version 2C, defines in RFC 1901 to 1908. Utilizes community string-based administrative framework, and the SNMP version 3, interoperable standard-based protocol, originally defined in RFC 2273 and 2275, provides secure access to devices by authenticating and encrypting packets over the network. The community strings. SNMP uses community strings that control access to the MIB. These are plain text passwords. There are two types of community strings: the read-only, that provides access to the MIB variables but does not allow these variables to be changed, only read. Because security is minimal in version 2C, many organizations use SNMP version 2 in read-only mode. Read-write mode provides read and write access to all objects in the MIB. Management information based object ID. The MIB organizes these variables hierarchically. MIB variables enable the management software to monitor and control the network device. The MIB defines each variable as an object ID, OID. These object IDs uniquely identify managed objects in the MIB hierarchy. The MIB organizes the OIDs based on RFC standards into a hierarchy of OIDs, usually shown as a tree. This tree for different devices includes some branches with variables common to many networking devices, and some branches with the variables specific to that device. RFC defines some common public variables. Here we can see portions of the MIB structure as defined by Cisco. Since the CPU is one of the key resources, it's a good idea to keep measuring constantly. The statistics of the CPU should be compiled on the NMS and they can be graphed. This is observing this over an extended time period that allows administrators to establish a baseline estimate of CPU utilization and set a threshold when this threshold is exceeded. You can send a notification. Here we can see the SNMP graphing tool that periodically polls the SNMP agents and it graphs its results. Here we can see are 5-minute samples of router CPU utilization over the period of a few weeks. The data is retrieved with the SNMP get utility issued on the NMS. This utility can manually obtain values of the average of the CPU BC percentage. The SNMP get utility requires that the SNMP version, that correct community, the IP address of the network, the device to query, and the OID number are set. We can see a command with that information, the version, the community, the IP address, and the OID number, and it obtains the CPU value in return. The Cisco SNMP Navigator website allows a network administrator to research details about a particular object ID. We can see an example with a particular OID in the image on the left. Steps for configuring SNMP. We first use the SNMP server community command with the string followed by if it's read only or read write to configure the access level. Then to document the location, we use the SNMP server location followed by the flat text in specifying the location. The same to document the contact, use the SNMP server contact with the name of set contact, and to restrict the SNMP access to NMS hosts that are permitted by an ACL and access list. Use the SNMP server community string command followed by the access list, either number or its name. To specify the recipient of the SNMP trap operations, this command SNMP server host followed by that host ID, specify the version and the mode and the string of the community. Enable traps on an SNMP agent with the SNMP server enable trap followed by the notification types. To verify SNMP configuration, use any of the variations of SNMP on the privilege exec mode command. To display information relating to the SNMP community string, or if applicable the associated access list, use the show SNMP community command. And among the security best practices, community strings, as with all passwords, have to be carefully chosen to ensure that they are not too easy to crack and should be changed at regular intervals. Ensure that the SNMP messages do not spread beyond the management consoles. In SNMP version 3 is recommended because it provides security authentication and encryption. NetFlow Operation. NetFlow is a Cisco iOS technology that provides statistics on packets flowing through a Cisco router on multi-layer switch. NetFlow provides data to enable network and security monitoring, network planning, traffic analysis to include identifications of the network, bottlenecks, and IP accounting for billing purposes. To understand the NetFlow. NetFlow is usually used for measuring who is using what network resources and for what purpose, accounting and charging back to according to the resource utilization level to do more effective network planning, and using the information to better structure and customize the set of available applications and services to meet users' needs and customer service requirements. NetFlow uses a push-based model. The collector simply listens for NetFlow traffic, and the networking devices are in charge of sending NetFlow data to the collector based on changes in their flow cache. NetFlow only gathers traffic statistics. Criteria used when NetFlow was created is that NetFlow should be completely transparent to the applications and devices in the network. NetFlow should not have to be supported and running on all devices in the network to function. Network flows. NetFlow breaks down TCP/IP communications for statistical record keeping using the concept of a flow. A flow is an unidirectional stream of packets between a specific source system and a specific destination. It received these types of flows, or at least originally did: the source IP address, the destination IP address, source port number, destination port number, layer 3 protocol types, and type of service, marking, and input logical interface. Configuring the NetFlow. Step 1. Configure the NetFlow data capture. NetFlow captures data from ingress, incoming, and egress outgoing packets. Step 2. Configure the NetFlow data export. The IP address or hostname of the NetFlow collector must be specified and the UDP port to which the NetFlow collects or listens. Step 3. Verify the NetFlow, its operation and statistics after configuring it. Then the exported data can be analyzed on a workstation running an application such as SolarWinds, NetFlow Traffic Analyzer, Elixir Scrutinizer, or Cisco NetFlow Collector NFC. Minimally, one can rely on the output from a number of show commands of the router itself. Here we can see the commands in the chosen interface. You configure the flow ingress and egress, and the destination and the version. To verify the NetFlow, use the show IP cache flow. You can see the packets in the image after the command is shown. Well, that will be all for this chapter. Thank you for listening.